Greetings and welcome to System. In the previous video, we discussed about thermodynamics in chemical reactions, in which we discussed about heat of the reaction, standard heat of the reaction, exothermic and endothermic reactions, heat of combustion, as well as heat of formation. So we discussed the different concepts involved in each of them, their definitions, and the ways to calculate these heats. So now we are going to go ahead and solve certain problems related to this. So the first problem is the enthalpy change for the reaction is minus 92.2 kilojoules. So this particular reaction is given to us and the enthalpy change is given to be minus 92.2 kilojoules. Calculate the heat of formation of ammonia. Now, by the definition of heat of formation, we know that heat of formation is the heat of the reaction when 1 mole of a substance is formed, right? When 1 mole of a substance is formed. Now, over here, there are 2 moles of ammonia being formed, right? There are 2 moles of ammonia being formed. And the heat of the reaction in this case is minus 92.2 kilojoules. Hence, if we divide the entire reaction by 2, then in that case, we'll get the heat of the heat of formation of ammonia. So in that case, we are going to divide the entire reaction by 2. So we are going to get half N2 plus 3 by 2 H2 gives us NH3. Now, as you can see, this particular reaction is basically forming 1 mole of ammonia, right? So the heat of formation of ammonia, which is generally represented by this delta HF. So delta HF is minus 92.2. And since we divided the entire reaction by 2, so we are even going to divide the heat of the reaction by 2. So it's going to be minus 92.2 by 2 kilojoules. All right, so that's going to be minus 46.1 kilojoules. Now we move on to the next problem. Calculate the enthalpy change for the following reactions. Basically, we have to calculate the heat of this reaction. All right, and enthalpy of formation for ammonia and water are given. Now, if you just have a look, we have ammonia, oxygen, nitrogen, and water in this case. Now, according to the rule that we discussed in the previous class, if we have a particular substance which has the same element, for example, oxygen, O2 has both atoms of oxygen. Similarly, nitrogen has both atoms of nitrogen, right? So if we have a particular particular substance of this form, then in that case, heat of formation of that particular substance is going to be 0, considering that it is in its standard physical state. So over here, oxygen's standard physical state is gas, and even nitrogen's standard physical state is gas. So that's why we can say that these two can have the enthalpy of formation as 0, right? So we only need the enthalpy of formation of ammonia and enthalpy of formation of water. So heat of the reaction, as we discussed, according to the definition, heat of the reaction is given by enthalpy of products minus enthalpy of reactants, right? So enthalpy of products is equal to enthalpy of nitrogen plus enthalpy of water, right? Now, since we have 2 moles of nitrogen, so the enthalpy of nitrogen is going to be 2 into 0, which by the rule we have got 0. And enthalpy of water is going to be 6, since we have 6 moles of water in the reaction. So 6 into the enthalpy of formation of water is minus 286. So we are going to have 6 into minus 286 joules, right? Oh, sorry, kilojoules. That is going to be the enthalpy of the products. While when we find the enthalpy of reactants, it is going to be enthalpy of oxygen plus enthalpy of ammonia. So enthalpy of oxygen is going to be, since we have 3 moles of oxygen, so it's going to be 3 into 0 plus, since we have 4 moles of ammonia, so 4 into enthalpy of formation of ammonia is minus 46. So minus 46 kilojoules, right? So in that case, the heat of the reaction is going to be 6 into minus 286 plus 2 into 0. This is the enthalpy of reactants. Enthalpy of products minus 3 into 0 minus 4 into minus 46. This is the enthalpy of reactants. So when we solve this, we'll get minus 1532 kilojoules. All right, this is the enthalpy of reaction. All right. This question can also be formulated in a different way. For example, over here, I have asked calculate the enthalpy change per mole of ammonia reacted. So this enthalpy change that we have calculated, if you see the stoichiometry, and according to the stoichiometry, over here, 4 moles of ammonia are reacting, right? So if 4 moles of ammonia are reacting, in that case, the enthalpy of reaction is minus 1532 kilojoules. However, if only 1 mole, since we have to calculate enthalpy change per mole of ammonia reacted. So if only 1 mole of ammonia is reacting, then as we did in the previous question, we'll just divide this heat by 4. So heat of the reaction per mole of ammonia reacted is equal to minus 1532. This is the heat of the reaction when 4 moles of ammonia have reacted upon 4. These are the number of moles of ammonia that had reacted. So in that case, this is going to be minus 383 kilojoule per mole ammonia reacted. Okay, this is going to be the heat, that is heat of the reaction, which per mole of ammonia that has reacted. Okay, then we have the third problem, which is similar to the second problem. Over here, we have to find heat of the reaction per mole of nitrogen produced. So in this reaction, there are 2 moles of nitrogen that are being produced. So in order to calculate the heat of the reaction per mole of nitrogen produced, so we have to divide the heat by 2. This is the heat of the reaction when 2 moles of nitrogen were reacting, and when we divide it by 2, then this is the heat of the reaction when 1 mole of nitrogen is reacting. So that is going to be minus 766 kilojoule per mole of nitrogen produced. All right, this is a heat of the reaction per mole of nitrogen produced. So further, when we will be dealing with other questions or other subjects, other concepts, then in that case, this is going to have a lot of significance per mole of nitrogen, per mole of ammonia. Because in that case, they'll directly give you that, okay, the heat of the reaction is this per mole of ammonia reacted, or this is the heat of reaction per mole of nitrogen produced. So in that case, you'll have to deal with it, and then you'll have to do material and energy balance. So in that case, it becomes a little complicated. So you need to be very clear how to calculate, or how do we calculate heat of the reaction, given that 4 moles of ammonia have been produced. 4 moles of ammonia have reacted, or 2 moles of nitrogen have been produced. All right. So this is how we can do the calculations.